Okay, to solve these problems using interest rate, you have to know which formula to use. If it says compounding continuously, you will use this one. If it compounds at any other rate, this is the one you'll use. Okay, Cynthia has $8,500 she would like to invest. So that is the principal. That's how much she's starting with. And so we're going to put $8,500 here. She found a mutual fund that would return 8.4% compounded weekly. Okay, 8.4% is the interest rate, and you have to write it as a decimal, so it's 0.084. Because you have to move the decimal 2 places. Okay, compounded weekly, there are 52 weeks in a year. So that's the number of times it's compounded. Then it says how much would be in the account after 3 years. That's the time. Okay, it didn't say compounded continuously, so we're going to use this other formula. I don't know what I'm doing. And so you're going to start with 8,500. That's the principal. Parentheses 1 plus the interest rate, which is 0.084, over the number of times it's compounded, which is 52, and your exponent is going to be n times t, and you can multiply 52 times 3, or you can write 52 times 3 right there. Put that in the calculator, and let's see, just to verify, 8,500 parentheses 1 plus alpha y equals, and that's going to be 0.084 divided by 52, arrow out, close parentheses, to the exponent 52 times 3, and you end up with 10,933 and 84 cents. Okay. Next says James would like to buy a car when he graduates in 2 years. He thinks $7,000 would be enough to buy what he wants. How much would he need to invest in an account paying 5.6% compounded continuously so that he can afford the vehicle? Okay. He wants to end up with $7,000, so that is your A. That's the amount he's going to end up with. P is the principal, and that's what we don't know, so we're not going to fill anything in there. And the number of times it's going to be compounded, that is compounding continuously, so we're just going to put an E there. The interest rate is 5.6%, so it's 0.056. And the amount of time he has is 2 years. So we're going to use the APERT formula. So the amount is $7,000, and it equals the principal, the amount you start with, which we don't know what that is, e to the exponent 0.056 times 2. Okay, in this case, since you're looking for P, you need to divide everything by this number right here. Let's see. By this number right here. So if you put E in the calculator, that is, let me clear that. It's second natural log to the exponent 0.056 times 2, and that is 1.1185. And what you divide one side, you have to divide the other. Now, I'm rounding it because I can't write this huge number down, but you guys don't have to. You could just do 7,000 divided by e to the 0.056 times 2, Mine's going to be an estimate because it just is. And it's going to equal $6,258.38. And that's the amount he would need. If you don't round it, that ends up being 31 cents. But it's either way, it's close enough. So the principal, the amount he's going to start with is $6,258.38. Okay? Okay, number 9. Amanda is looking through investment options. Option 1 is a bond that promises to pay 8% in 6 years, compounded continuously. Option 2 is a stock option that promises 10% in 5 years, compounded quarterly. What is the overall difference between these options if she has $2,000 to invest? Okay, she's starting with $2,000 in both cases. So we're going to put $2,000 here. The first one's compounded continuously, so the number of times it's compounded, we're going to put E. It's at 8%, and you would write that 0.08, and the amount of time is 2 years. Okay, the other one is going to be compounded quarterly, so it's 4 times. The interest rate is 10%, and it's compounded for 5 years. Okay, so we're going to put this in the calculator. Because it's E, you would put in 2,000 E to the exponent, and that would be, the exponent would be R times T, and so that would be 0.08 times 2. Okay, then over here, oops, it's going to be compounding quarterly, and so that's going to be 2,000 times 1 plus 0.1 over 4 to the exponent nt, so that's 4 times 5, so it's going to be to the 20th. Okay, so I'm going to put the first one in the calculator, which is 2,000 times E to the exponent 0.08 times 2, and you get 2,347.02. This other one's being compounded for 5 years, more than twice the amount of time, and higher interest rate. You should get much, much more. So we're going to start with 2,000, and it's going to be 1 plus, and I did alpha y equals, put 0.1 in the numerator, 4 in the denominator, close the parentheses, and this is to the exponent 20. This one is going to be $3,277.23. Okay, they didn't ask which one's better. They asked what was the difference between them. So you're going to have to do $3,277.23 minus $2,347.02. So I'm going to subtract 2,347.02. The difference is $930.21. So here's the answer to that problem.